So, I am going to introduce what AI or basic machine learning is. I am not going to assume that you have any background. How many of you have background in machine learning? How many of you can tell me what AI means, what those abbreviation means? Okay, that means everybody knows. Okay. So, then I am going to talk about some of the machine learning models, because these models I am going to use throughout this course to do different kind of cyber security detection. And then once we have some understanding, hopefully this would be before the tea break, and then after the tea break we will talk about explainable AI algorithms. So, the point to start machine learning is starting with programming. All of us, we know the programming. We write a program, we write some program, and then if give some input data, it produces something. If you are sorting if you are sorting algorithm, you are trying to sort, you write the algorithm, you give some data, it gives you a sorted list. Only thing is, story gets little swapped in case of machine learning. You give the output, you give the data, it gives what program it was by. So, any machine learning algorithm, you give a set of data and then you ask or use it to kind of predict something, predict or regression, we will get into that. But basically you are trying to, from the data, you are trying to figure out certain behavior, characteristics, certain story, and then that program you are going to use, that model that is building, that model you are going to use, that program you are going to use for subsequent process. But starting point is output, starting point is, so this is basically the kind of story, it is just the story get little swapped. And before I go any further, I wanted to introduce few terms. Model, in case of machine learning we keep saying model. So, then what is the difference between machine learning itself and the model? So, basically once you give some data, the starting point always is data from somewhere, it depends on what context it is, and from that data the system learns something and it builds something internally. Whatever it learns or builds, that is what we call as a model. And once it builds while it is building a model, the notion of feature is that when it is building a model, it is trying to figure out what is important and what is not important, and that is basically a feature. For example, if you are giving a lot of data set with lot of fruits, apples, oranges and all that stuff. So, a typical feature would be like color, smell, taste, assuming your data set has that information. If you did not provide that information, then that is a different story, we will get to that later, but that is a feature. The people who are successful in this world, they actually do the right feature extraction. They spend their time very carefully. They do not waste their time in Facebook and all that nonsense. They invest their time very meaningfully on right things. It is not that they are spending 16-18 hours a day, they may be, but whatever the time is spent, they always calculate return on investment. That is the right feature. And why that feature important? Let us say, for the sake of argument, color, the machine learning process, it did not use color as a feature. And then you are asking it a lot of questions to that model by giving lot of colorful fruits, all they look exactly the same, and showing images and then asking, tell me, is it apple, is it orange, is this, but it never learned the feature of color. Based on the color it cannot distinguish. So, that is of no use. So, right feature, whether it is learning by itself, we will talk about that, or you are telling it, helping it, please focus on the feature. When you are planning to find your life partner, everybody will tell you, all the elderly ones, do not focus on the look, focus on how good human being this, how much fraud this person is, focus on that. Is that fraudness matches with your fraudness? All of us are fraud, take it from me. It is just that what you think is right, the people who actually murder, they also have a philosophy. This person should have been killed, this person has a lot of money, that money should have been taken, I am Robin Hood, I will take that money, I will distribute in poor. Everybody has a justification philosophy why they do what they do. So, this feature is exactly that attribute, the quality, the values. When you find a life partner, what are these values that are kind of compatible with yours? Whether the kind of you see the comedy movie, whatever you do, that is the feature, that is the matching feature. Many of those matrimonial sites, they actually use that feature. Either they explicitly ask you, when you are wasting your time going through those clips in your whatever website you are doing those surfing, they actually very quickly figure out, based on in which of the videos you are pausing longer, which of them you are going back seeing it very quickly, within few minutes they will figure out exactly what you like, and it will make sure you waste your time there while somebody else is making money. Then there is a notion of label. So, when you are training in machine learning, there are two parts. We will get into that. One is training, which is right bottom, then you have prediction. So, when you build the machine learning model, you have to train it. If you never showed me any picture of an animal and then you ask me, tell me what animal it is, I do not even know what animal means, forget about distinguishing. So, during training time you teach, and during teaching each of the data you have to label, this is apple, this is orange. Then during testing time, this is the prediction time. Now you show another picture which is not the set of pictures you have shown, it is not the exact picture, maybe apple slightly smaller pictures, bigger aspect ratio or different type of apple. Maybe you have shown it a Kashmiri apple, now you are asking for a Fiji apple. It looks slightly different, but if it learn the right feature, it will be able to tell it is an apple, not an orange. That is the prediction it will be able to do. So, then these are the things. Now, label comes in the context. During training, when you are saying this picture is an apple, somebody gave you a set of data with bunch of images. Somebody has to manually go through and mark on them when it is training the data set. Here is a picture, it is an apple. Here is a picture, it is an orange. Here is a picture, it is a grape. Somebody has to do that. That is the labeling task. Now, do I need label and all that? There are different variations. Any of you have any question on these words? Because as I go along, I will be using these words comfortably. Model something machine learning you build, some internal data structure, think of that, internal data structure that it builds. Of course, most important thing is data set. If you do not give any data, so if you do not give any data, then there is no starting point. Once you give the data, machine learning tries to find the model, but in that process you have to either it has to learn or you have to tell it what features are important. If it is focusing on wrong features, you get attracted to somebody who looks handsome or beautiful, then it is fundamentally flawed relationship right there. If somebody is a wonderful person and plus beautiful, that is fine, that should be a secondary feature. The labeling, when in the training process for a trained eye, apple, orange, that labeling, training is basically model learns, and then prediction is when you use that machine learning in the field. So, during my all discussion I will separate always training time and prediction time. Why? Because training time, it is okay you spend 2 weeks, 3 months, gigabytes or terabytes of data you train it on. Like the way large language models are built, you need nuclear reactor to power them. It seems nobody minds. But when you are using that large language models to make the prediction, if at that time you need nuclear power, then it is a problem, because your car cannot use it, it does not have the power of amount of nuclear reactor. So, prediction time has to be low power, very quick. You show an image, it sees a pedestrian, it realizes it is a person, immediately it decides and puts the brake on. It has to be that quick. So, you are not going to waste time. So, that is basically prediction. Any of you have any question on these 5 terms, or some of the terms seems like they are same? Now, learning has different variations. I am going to talk about 2 major variations of machine learning, supervised and unsupervised. But before I go there, let me take a tiny test. So, let us say a kid is trained by showing a cat and dog. Your family has a cat, your family has a dog, or you have seen your baby on the street. Now you take the baby to the zoo and you show a tiger. I want to see hands. How many of you think the kid will be able to say it's a tiger? How many of you think kid would be able to say it's a cat? How many of you say kid will be able to say dog? How many of you say kid will say basically, which means I don't know, I don't care. Kid will always say it's a cat, because what kid is doing or the kid's mind is doing, because it's called AI or artificial intelligence, not for just for the fun. It's because this machine learning or this whole ecosystem is built around the idea that can we mimic the human brain. That's why the word AI. And the way these kids' brain work, it's learning some feature, knowingly, unknowingly. I'll come back to this kid's example later. It will call cat. Why, what, we'll come back to that. So the supervised learning idea is that when you train, you give level data. Remember the leveling? Every image, you put a tag saying it's apple, it's orange. I'm taking example of images, but it can be on text, it could be on anything, video and all, audio, all that stuff. So you put a label. The difficulty, the good side of supervised learning is basically the model you build, that's very good. How do you know good? One of the metric is prediction accuracy. If you train enough, it may be able to predict with 90%, 99% accuracy, whether it's a cat or dog, right? But the predict supervised learning, as the name suggests, you are supervising it in learning process. How we are supervising? By tagging or labeling every data with what it is. If you teach your machine learning model only cat and dog, don't ask a question, does it have a tail? Don't ask that question, because it doesn't even understand what tail is. If you really want to do that, then you have to tag accordingly. This cat has tail, this cat dog, somebody has bitten the tail. You have to put that. You have to put that in so that the model it builds it correctly. In supervised learning, don't ask a question, something you didn't train it on. So for example, here I am showing some stuff. So you have bunch of male and female gender, age, salary and all that stuff, and then maybe once you train with this, then you want to basically certain characteristics, whether they purchase something or not. So then once you show another item or an individual, would this person purchase or not, that's what the supervised learning is basically going to do, yes or no answer. And this is also commonly known as classification. So supervised learning has two types of categories. When you need a yes no answer, like cat or dog, binary answer, then it's basically classification. But when you need actually a value, then we call that as a regression. So the basic underlying concepts are kind of similar, as you can imagine. This is much simpler model, this is a little more complicated model, and I promised I will not get into the probability or statistics, but there are a lot of ideas inbuilt in there. So if you are thinking of this particular example, you are teaching it for a different temperature, pressure, relative humidity, different parts of the globe, the wind speed, it is teaching certain things about the model. Now you are asking, today is Monday, the February 13, tell me what's the wind speed in Guwahati, then it gives you a number. I am just making it up, 2.4 kilometer per hour speed. Now what is the actual speed? How far you are, that's the error. That's the accuracy loss or accuracy gain. Whereas here, if I ask 100 question, what percentage of the time it's correct, that's the prediction accuracy. So the notion of accuracy or error is slightly different, but here it goes yes or no, like cat and dog, apple or orange. Here is actually you are going for a value. Here you make a mistake during training, you basically it classifies a cat as a dog, you try to figure out why is it. Was there in the original picture when I trained, some of the cat was looking like dog, there were breed and all that stuff, did I misguided, do I have to train little more, right. So this is different type of breed, it never learned. Here it basically the error you get the prediction of the wind speed versus actual speed, you feed that error back, and of course there are equations, statistical regression, that is the idea. So, for this 2 weeks all we need to understand just the supervised learning, somebody is helping you. The other side is unsupervised learning. So, unsupervised basically nobody is supervising, right. So, supervised learning would be a parent telling the kid how to walk, where to go, not to go, do not go to the water, do not go near fire and all that stuff, do not put the water bottle near the table and all that stuff. But kids always intensity would be exactly whatever you ask, they will do exactly the same. So, this is basically actually good learning for parents. Those of your parents probably you do, if you do not do, I learned it from machine learning. I always ask my kid the opposite. It worked until he was 8 years old. Reverse psychology. If I did not wanted him to keep it here, I always ask him, do not keep it in the middle, try to keep it on the boundary. He would always push it away from the boundary. That is exactly what I wanted. But after 8-year-old, it did not work at all. He always still keeps saying, you keep saying you do not lie, you lied all your life. Now, you have to live with that. You have to live with that, right. So, unsupervised learning analogy would be, let us say think of an orphan who does not have parents or no elderly relatives. They are learning from mafia and people on the street, and they are getting total crazy, they do not know what is right and wrong. That would be unsupervised learning. Even there people learn, people live, they also make amazing things. Anybody has any question on supervised learning, the data set is the input, every data you have to level and train for a long time, how long and all that stuff. So, in this context two terms are very important, one is false positive, another is false negative. Let us take the simplest situation, classification, to talk about it. You showed an apple and it said an apple, it is perfectly fine. But if you showed an apple and it said an orange, right, or something, you let us say you showed an image of an MRI and it came up with saying it is not an cancer, but actually is a cancer. That is basically is a, in a medical terms it becomes little twisted. When somebody says yes you have cancer, that positive is actually not a good positive. So, that is basically a false positive. It said yes. So, basically your tumor or cell is cancerous. The machine learning model looked at the picture or MRI and said yes, that is a false positive. And then if it says no, but actually the tumor, there is a tumor or cancerous cell, that is a false negative. Both are dangerous, because if he says yes you have a cancer, people can have a heart attack and die, and if it says by mistake you do not have a cancer, you do not treat, go to the fourth final stage, people can still die. So, both are dangerous. So, therefore, having false positive or negative is not a great thing to happen. The prediction accuracy of 100% would be ideal, but that does not happen, you could quite realize. If you train too much, that would be also problem. If you train too little, that is also a problem. Again, let us go back to the child. In the child example, if you just say do this, do not do that and all, the child does not develop his or her own thinking ability. For the rest of the life, when you are not next to that person does not know what the hell to do. In contrary, if you never said anything to that person, you are just waiting, that kid got into these drinks and drugs and all that stuff, and you are like, oh, why did not I intervene on the moment, why did I waited for the kid to make right decision, mix with right people, that is also dangerous. Kid will go to the water, figure out, but that would be too late. So, let us take an example of a supervised learning. There are many examples. So, support vector machine is one of the earliest, from 1950s, 60s people are using it. It is not that popular these days, but what it does, it basically by looking at the data, trained data, it kind of plots. So, think of this data, some kind of size. So, two parameter it looked at, the size of the tumor and where kind of that thing is, or in that scale, and you put kind of different places. The cell is malignant, cancerous or non-cancerous cell based on that. And basically when you are training it, you labeled it. You told the system, by the way, this particular point is basically cancerous, this particular point non-cancerous. Now how does that happen? So in medical terms, doctor already has a database of the cells. They will hide the identity of the people, all the cell, whatever cell characteristics and which one was cancer cell. Think of an image. You are showing the machine learning tool images of cancerous cell, non-cancerous cells from different patients of different color, different gender, all across the globe, lot of data set, and everything you has marked, you are showing. And after showing all of that, think of you are a human being. This, ignore this red line for a moment. This data set is given to you. Next time, this is during training time. Next time somebody gives you a data right here, what would you say? It's malignant, because you know most of the stuff here. Ignore the line for a moment. Or somebody gives a data here, then you know that's kind of benign, near the benign ones. But somebody gives something else, kind of tricky. So when you train, what the machine learning model, or I keep saying the model builds, actually builds a line like this. Here I am doing a 2D line. In general, it could be a complex n dimensional plane. It may not be one contiguous plane, it could be multiple planes and multiple stuff. But still there is a notion of you are my friend or you are my enemy, you are with me or you are against me. There is no notion of neutrality in classification based machine learning. And in support vector means once you build a line, then now this is the training time, this is done. You spend 3 months, 6 months training this. Now during usage, we call it prediction time. I went to the doctor's office, there is a tumor, doctor took the whatever thing, biopsy, and then from the that report basically showed that to the system, machine learning tool scanned it, and it basically find the point based on these two parameters, find the point somewhere, and if the point is above this line, then it's basically cancerous cell. If this is below this line, then it's basically good cell. Anybody has a question with that? Now the problem comes with false positive and false negative. Now let us say there is a point, let us say point is right here, then based on this line the model will say it's a cancer, but it turned out that person does not have cancer. For more tests or whatever second opinion, then you have to retrain the model. Maybe a new line will be drawn here, the line will be bent there, so new training and all that, if that is possible. And that is kind of a common feature. Whenever you have a car that runs on some level of automation, then it has a machine learning model that was trained. When you bought the car, it comes with well trained machine learning model, but new things it's learning depending on the roads you are driving. That original modeling time it didn't know. So that all of that learning, when you park or charge depending on the company, then it will send that data back to cloud, and that new trained data will come back from the cloud. So whether cloud will make the decision, that normally does not happen, because that takes a lot of time. Normal decision is based on the model that is on the car right there, but then there is a upgrade based on when you are charging in the night or all that stuff. Will the cloud, new modified model comes in based on the mistakes you did that day. So the notion of retraining is not new, but in this 10 days we will ignore retraining, but retraining is real life, but we will ignore retraining to avoid confusion. Any of you have any question on how supervised learning at the simplest level works? You trained it, it built a line or a plane, some separator, good versus bad, apples versus orange, cat versus dog, street cat versus good cat. Just by looking at it, can you figure out cat does not have, let us say, a locket or can you figure out is it a home cat or is it this? Assuming there is a machine learning model which can do that. Or it would be even better if somebody builds a model just to put on the face and figure out good person, bad person. That would be wonderful to make friends, right? So we talked about now unsupervised learning on the other side, the way I talked about orphan, where you basically you do not give it a label data, it just learned by itself. it learned by themselves. And how do they do it? Of course, I have to mention that unsupervised learning is more challenging. How do they do it? By clustering or association. What is clustering? So, basically when you give a set of data, you try to figure out that it belongs to certain cluster. For example, if lot of purchase data is given, people and what they purchase, based on the types they purchased, whether it is electronics versus clothes, or whether somebody is buying Samsung electronics versus Apple electronics, it forms a kind of group. Now you put in unknown people, let us say you put Professor Chandan Karfa, then it should be able to decide whether he is going to buy Samsung TV or Sony TV. It would be able to predict that. If you ask, is he going to buy a Samsung TV, it is going to say yes or no, because it looked at that and formed that clustering. Now, association, basically by looking at the feature or data, it basically figures out if somebody buys milk, they are also going to buy bread. Now, this has been in use for a long time. Most shops put some of those stuff in USA near the door, because most people, they figured out, they are running in there and quickly they want to take something for breakfast, cereal, milk or bread. They have their individual dedicated sections, but these will be kept there. So, based on that they made association. If somebody buys this, they will buy that. So, even in the dedicated aisle, they might even keep some of those stuff, but actual main aisle, they may have more milk, different varieties of milk, but that association they make, and that is how. Or it also works when you went there to buy a phone, they will try to sell something else, because their data set analysis told them that people, if you can pursue somebody to buy something when they are doing something, they are likely to do it. If you have gone for visa interview in any of the US consulate, the auto people, if its normal cost is 100, they will ask for 500, and they will tell you, I will tell you exactly what they say. Normally 1 out of 500 people get their visa approved, and you are one of those. It is kind of gaining a lottery, this and that, and you will be so happy, you would be willing to give that 200, 300 to that auto guy. So, even the autowalas these days understand the idea of unsupervised learning and association simply by looking at your face and your happiness that you got the visa. Everybody does it, and that is exactly these models are trying to do. And there are many examples, K-means clustering, a priori algorithm, and so on and so forth. So, here is an example of a K-means clustering. You are plotting certain data, and as a human being, how would I cluster them? I am simply seeing which points are near and which points are far. The problem with unsupervised learning, what is the meaning of near and far? Is it a Euclidean distance? Is it a social networking distance? Is it feelings? What is it? Emotional Q, IQ, what is it? So, the metric is difficult, which I am not going to get into detail, that is a semester course, but think about it, the way you manually look at and figure out based on certain characteristics or features, either they are near or they are far. Think of Euclidean distance, if that makes you easier to visualize. Think of stars in the sky, the kind of stars or cluster or galaxy they are near, it is all relative. But if you zoom into that galaxy, there still might be hundreds of light year away from each other. But from your perspective or the scientific experiment you want to do, for them all you have to distinguish, are you near Milky Way galaxy or far away from Milky Way galaxy. That is all you need to know. Are you a social influencer? How many followers you have? That is a cluster. Or maybe you are also a social influencer, but I think if I am selling soaps, I want to pay money to you than that person, because that person is kind of more for clothes kind of stuff. So, that is kind of the unsupervised learning. The good news of unsupervised learning is the headache of training, where you have to level the data set, you do not have, and you will not know how much pain it is until you are starting doing some research. You have a tons of data, somebody has to painstakingly go through for millions of data and put a level, and anytime you try to automate and script, you know how it works, and then you try to figure out why prediction is so bad. It is basically fundamentally flawed. Which one is buggy? Any question on which is the very basics of machine learning. You give some data, it builds a model, think of builds a line or a separator left or right. So, typically separator left or right is on for supervised learning, and cluster basically it kind of tries to draw a circle, either you are either within the circle or you are outside the circle. If you are within the circle, that is a cluster, and somehow it figured out that if you are within the circle, then it is a cat, if you are outside the circle, it is a dog. It still does the prediction, it still does the regression. So, prediction and classification and regression is orthogonal to whether you do supervised or unsupervised. But of course, typically that is not the usage pattern. As I said, milk, butter and all that usage pattern is different. Any questions or very basics of machine learning? Let me take a test. How many of you can explain me what is a feature in layman terms? I want to see hands. Yes, please.
The individual characteristics, let's say for a table it is the edge or maybe the color.
Thank you. Thank you, that will do. Anything if you understand in layman terms, then we are together. You will be able to follow everything I teach. Now, I am going to zoom in little bit deeper, the models that we are going to use for cyber security detection, lot of buzzword, but I will break it down to layman terms without using any equations except once. So, now I want to talk about what we talked so far. You have a data set, then you do feature engineering or finding features, then you have the feature, then like support vector machine, you build a line, and as you can see in this line some different type is also in the left. So, maybe it happened during retraining time or whatever it is, but build the time and then basically during prediction you kind of predict correctly, right. But for other approaches that you are going to do, you can have a raw input, you have a kind of neural network model, and then you have the output. So, neural network all of you probably know, but it is still the basic idea, the way it is different from whatever we talked so far is basically. So, basically each of the edges here will have a weight, some weight 1, then this might have weight 2 and so on and so forth. So, basically then you are computing the summation. So, for example, for this particular one, when you are computing the, it is basically computing Wi multiplied by xi. So, what Wi is the weight and xi is that link there or not there. So, for example, this one is connected to all 3, but this does not have to be, or maybe there was another node it is not connected to. So, that means xi for this one is 0, and so Wi xi when you compute, that basically means what is the contribution of this input on this node, and this story continues, and eventually somehow this information would be used to final prediction cat or dog. So, that is the notion of neural network, layers of, and these ideas would be useful because people use neural networks today in some variation of it, and I will show a lot of variations, and most of the acceleration of these neural network basically tries to do how do I compute this multiplication as fast as possible, whether in FPGA or different technology. There is a whole day dedicated to different way of AI models and faster acceleration, but this is basically the idea. So, as you can see, this feature engineering and all that, it actually does not build any of these complex structure, it only builds just a line. Somehow in some manner it builds a line, and you might say how that line is. Think about it, if this is kind of some x is a distance or size of the tumor, forget about this complex line, think of a vertical line x equal to 5, that is the line it builds. That means now you showed a picture of a image, all it will measure the size of the tumor. If it is less than 5 centimeter, yeah, it is good. If it is more than 5 centimeter, that is bad. So, the actual machine learning model is nothing but x equal to 5, that is all it is. Machine learning model is equal to x equal to 5, that is it. But in deep learning or any of the neural networks, machine learning model is a complicated structure. there is lot of nodes, lot of edges, lot of weights. How these weights computed, forward, backward, I won't get into those details. Based on the data, these weights should be determined. How many layer do I need? 1 layer, 2 layer? Do I need a softmax layer at the end? There are a lot of research in this domain. Now, just to give you an idea, the way I talked about security conferences, there are lot of, if you are publishing, and Dr. Korfa talked about these ideas, that if you want to do research, publish only in top places. What are those top places? CVPR, AAAI, NEUR IPS, ICML, ICLR. So, there are these top conferences, and some of these conferences, let us say just take one example, ICML. Typical submission is in the order of 12,000 papers, 12,000 papers per year, and they typically accept about 3 to 4,000 per year. It may seem like 4,000 is a lot, but you see, it does not accept 8,000 papers, 9,000 papers. So, that is why if anybody told you they are expert, they know everything about AI, they are lying. There is no way a human being can read 4,000 paper accepted in each of these conferences on an average. 5 to 6 conferences, that is like 20,000 papers, accepted papers. Then there are people when their paper do not get accepted, they put it on archive. There is no way a human being can read all these papers, it is not possible. You need whole life to read 20,000 papers, that happens in 1 year. Now, you do the math, you understand what I am talking about. But the rationale I am trying to get in here, that all these conferences and places, people are innovating new and new ideas of how do we do neural network, how many layers needed, what happens in general or for application domain. For automotive system learning method, these kind of structures are better. Just to overemphasize on my last statement, I will show you few example scenario. Any question on this one? All I want to convey that the basic idea support vector machine I talked about in the basic machine learning, and what I am talking about now is drastically different. So, this is basically trying to build neuron like in our brain, unless you figured out already, synapses, the way synapses combine and synapses split, combine and all that stuff, that is basically how it is. Although we are far away from AI, irrespective of who told you what, actual human intelligence, because no matter how much computations we do, and if you are not sure what I am talking about, the robotic hand, high-end robotic hand costs somewhere around $50,000 to $70,000. That is why if you look any of these early days cartoon things, just look at their finger, they are like this. If free YouTube videos, most of them, unless you are seeing some Disney or Pixar movies, all cartoon characters fingers, they are not moving, they are like doing this or head, something like that. Because doing these millions of finger movement and looking lifelike, it is a millions of computations, and no matter which person you talk to, how dumb they are, or you think they are the dumbest person you have met, ask them to pick up an object, and when you see how they pick up the object, effortlessly they pick up. For a robot with supercomputer installed in it, it will not look natural, it would be still like this and that, just to pick up a penny, and then you touch that thing, it would be like hot, as if it has done so much of computation. Touch your own brain, it is so cold. That means brain can do low power computing, all these neural network computation so effortlessly, so low power manner. That is what people are trying to do in a natural world when they try to accelerate, low power acceleration. They are trying to match the speed of human brain and low power of speed they are able to get, but low power it millions of light year away, millions of light. It's basically this is running in 25 hertz, and processors are running in gigahertz, that million times faster processors are running. Still their robot finger movement looks so artificial. Anyway, until one of you can invent and come up with something, we are stuck with this neural network. As you can tell, I am not happy about it, but I am not smart about it either. Any question on this thought process of going for basic idea of machine learning to what is happening today? I am going to further build on this one for when I go forward. Yes, please.
What is WINX? I understand again, please.
WIXI, yeah, weight multiplied by the age, if there is a age.
Weight of this, weight of what matter? Which weight?
So, weight is between two nodes, there is a line, and that line will have a weight. And with the simplest way to visualize, let me draw something here. Let's take a simple example of just two node, color, that is one of the feature, okay, and let us say weight, that is another feature. Of course, I should not have used weight, because now when you are making decision, let us say this is the decision node, no multiple layers, no complex neural, that is all is the decision. But the color I am attaching 0.7 and here I am attaching 0.3. So, that is how decision would be. When a new object is given, I am going to look at its color and with 70% weight, and I am looking at the weight with 30% weight, and then total whatever value it is, then if that value is more than 5.5 whatever, I call it cat, otherwise I call it dog. So, that is the feature. Which feature is, of course, that is not what happens in neural network, something else happens, but that is the basic idea. The weight comes from if this feature is enabled, then how much of that would propagate to the next layer or next node. Does that answer your question?
Yes, sir.
The weight is basically something related to previous node in a general sense. In this example, it relates to that particular feature. How important with respect to other features. So, basically there are books on that, how many layers, and the easiest way to answer that would be you try with one layer, see the prediction, you try with two layers, then you see the prediction, try with different level, different number of features, then see the prediction, and you see whether your prediction is improving. And I will introduce the idea of gradient descent, then you kind of figure out, do I keep adding nodes, do I keep deleting nodes, do I keep all the edges. And this has lot more repercussion which I was not planning to talk. Just to answer your question, people actually try to see, can I get rid of some of the edges, yet I maintain the level of accuracy. And why? Because remember, all these weights has to be maintained in the memory, and all these multiplication has to happen. But if one of the weight is, let us say 4.1, another is 3.99, or one is 4.0, another 3.99, do I need to maintain those, or I can make both up 4.0? If some weight is really small with respect to other, can I get rid of them? That is known as compression. So, that is Songhan's work, and just by doing that basic idea, that was one of the first paper on compression, neural network compression. It is simply data compression. He basically said in layman terms, if there are a lot of values really smaller with respect to the other values, just make them 0, which is basically means get rid of those lines. And if there are multiple values with very close of them, make them some number in the middle, yet accuracy will remain comparable. Then you get significant savings, number of multiplication goes down, amount of memory recovered goes down, and he is a professor at MIT. The work is not that complex, but it is just that the impact of that work, everybody is using it, that is powerful. So, the number of layers, what is needed, and there are a lot of research on gradient descent, going forward, backward. Some of them are additive based algorithms, some of them deletion based. You start with layer and then you start deleting and see what happens. There are many such features. Any other questions? Yes, please.
So, in the traditional ML model too, the separator is also created on the same idea, like with some weight or some color based?
Here?
In the traditional ML model.
The separator is created based on what you observed, right. So, in this particular example line was there, but in general line should have been like this. It probably tried and could not do it, because that thing is the blue one is a good type. So, you want to draw a line or plane such that all blue ones on one side, all red blue circles on one side, and all red crosses on the other side.
Probably if you transform to other dimensions, you might
You might be able to. Thank you.
That's
Thank
the
you.
neural network what they're trying to do is actually trying to transform from regular domain to other high dimensional low dimensional, so that you can visualize. If you are not able to see from this angle, try to look at from other angle.
From other angle or another dimension, you might be able to draw a separator.
Maybe neural network that's trying to do that, nothing else. So creating dimension. Every layer is creating a new layer.
Yes, please. Every feature actually creates a dimension. That's a wonderful visual. I forgot all about it. Yes, please.
You are talking about the model being very complex and computationally very effective. So, what do you think is the most essential parameter which determines this, and what way we can work on it to reduce this complexity?
Right. That's exactly machine learning. Machine learning exactly tries to figure out automatically which feature is more important. Sorry, say again.
In the deep learning, not the traditional.
In deep learning, it's trying to figure out that one.
Yeah, I'm asking like what is that we can work on to reduce this complexity?
Right. The complexity, as I said, the number of layers you can reduce. But if you do that, if your accuracy goes down drastically, you wanted to save your power or make it faster, but low prediction is not acceptable. So basically, then training is essentially putting the weights on them. Either delete. So actually, forget about deletion of the edges. Deletion of edges is making a weight of 0. So it's trying to determine the weights of each of those edges. That's basically deep learning process. And during testing time or real world deployment, you basically provide the input and it would make the decision.
So on the hardware part, so what do you think is the most essential part for this deploying the deep learning?
Hardware part is the multiplication. So you have so much of, for every node, it's basically multiplication of all of that, and so it's basically multiplication followed by node. It's really all about multiplication. If you can do a lot of multiplication efficiently, and as you will see when you talk about tensor processing unit, if you can reuse some of the computation done by previous stage and all that stuff, that's the systolic array architecture in 1960s done by IBM. It came back and Google tensor processing unit made use of it, but we have a dedicated lecture for that. I will come back to that. Any questions on basic machine learning and how these two are different? Okay, now that we introduced machine learning, let us go to the little bit of insight into the model training. So then there are two important aspects, training and testing or prediction, training time and actually real world uses. And I want to repeat again, so that training time you spend 5 days, 5 months, nobody cares. But testing time, as long as it's low power, fast, accurate, that's all people care. Same thing about when Dr. Karpa is going to talk about compilation in embedded systems domain, where I come from. Even if your compiler takes 5 days, nobody cares. But if that compiled code takes low power, runs extremely fast, meets real time guarantees, that's what people care. So for malware detection, for example, how would training happen? You have a data set, so this is a data set of which register has what value in what clock cycle, that is your data set, and then you will have some kind of, either you choose or you kind of, somebody told you what would be useful, you use some kind of recurrent neural network, some form of neural network, and then the training strategy is basically gradient descent. This is people normally use. So basically, the key idea is you start somewhere, think of the weights you assigned or whatever you do, and then you keep changing weights of different edges, keep removing some nodes, keep adding layer, and every time you are seeing, am I going to the, so here gradient descent idea is the lowest point is the point where it would make better prediction. That is the whole idea. And the analogy would be, you are on top of a mountain and the objective is you are blindfolded, you have to go down to the valley. You saw once whatever you wanted to see, and then you got blindfolded, and of course it is not a smooth terrain. You are going to hit bunch of trees and ponds and whatever stuff, you have to go to the valley. So but when you hit something, you take left, you take right, those are the gradient descent. So your leg is telling you this surface is going down, this surface is going up. Now that is a local optima, because even if some surface looks like up, maybe 5 minutes later it will go down faster than the surface that looks like it is going down, but it might be down and then wandering around and never going to the valley. And this classical problem you cannot, you do not have a full view, that is why I said blindfolded. Even if I do not blindfold you, think about bunch of trees and forest, and you do not see all the way to the valley. All you see two street. In general, it is more complicated than that. Two street, one goes like this, one goes like that, and your intuition will say some street which has a lower slope has higher likelihood in going to the valley faster than something like looks like this. But globally you do not know what will happen 5 minutes later, you have no idea. So that is basically gradient descent algorithm is trying to do optimization, but the key idea is every move it does, removing a node, removing a edge, changing a weight, am I getting lower value in terms of this value, am I going down better accuracy, or am I doing worse. So that is basically the optimization you do, and then there are many other mathematical formulations, so that you kind of say you do not make lot of bad mistakes and end result you assume I will be a billionaire, that is not going to happen. Any questions? So these are the kind of key ideas in high level lemma terms, in details are different. Now I am going to get to one of my favorite, zero shot learning. Let me explain you the context. You trained with the horses.
In your previous slide,
yes, please.
Malware detection. Title was malware detection.
It's a so we have a whole day for malware. So we will get to that, but this one is malware detection, because in malware all the publications they basically use recurrent neural network, they use gradient descent, and they use this kind of time data structure. So some data across clock cycle. So this has been known and understood, but if this was not understood, if this was not malware detection, I cannot put these three names next to each other. It could be anything, it may not be gradient descent, that might not work. It may not be recurrent neural network, it could be some other neural network, and it may not be the trace buffer data or the data I am showing. Maybe this data type, this data has to be reformatted differently. So these three major steps I just showed. Training strategy for all machine learning, you need a training strategy. What strategy worked for malware, or at least the ones people published, this one worked. But it is not guaranteed to work for other scenarios. We will show a lot of other scenarios like image generation, like large language model, I will show in a minute if time permits, right. Does that answer your question? Okay. So now zero shot learning is my favorite. The idea is that you can train with the horses and then you can test with the zebras. Or that I think that example is still silly. You train with horses, ask with apples and oranges, ask that model to classify between apple and orange, which I have never seen in the life. So there is in between I did not talk about. So supervised, unsupervised, you train a lot, then you ask on the same type of data set, that is assumption. Zero shot learning is basically on a different type of data set, and it still should be able to make right prediction, and in between there is something called one shot learning, and the key idea is you train with a data set, you can spend 3 months, it is all right, but now before testing on a new domain I will give you 5 minutes, 10 minutes, you want an hour a day, it is all right, that is it, you are not going to get 3 months for training. How do you do? So there are a lot of examples, and even in a lot of Indian projects, lot of US government projects. So for example, there was this project on autonomous vehicle project. The first project DARPA started is that how far can you drive, or your autonomous car, you can't have the remote, how far can it drive on a desert in between Las Vegas and Nevada, one of those deserts. So you can train your car or whatever model you have, whatever things you want to tell it, how many cameras you want to build, how fast you do camera processing, it is all fine. But when you go to that terrain, terrain was not disclosed earlier. When terrain was shown to you that it is a desert and you can see whatever you can see, how far, if you want to tell it certain things, that is all right, but you have 15 minutes, half an hour, 1 hour, then whenever the DARPA program director says go, you have to let your car go, and whichever car goes the farthest wins that $1 million. Those days $1 million was a lot of money for researchers, so you can win that $1 million prize. And these days I am part of that project called Tiamat. This also has a $1 million prize that goes to pocket actually, not to the research. That prize is your model would be trained in a different territory and it would be tested in a different territory, and that example is so think of a robot or an agent moving into a simulation environment where this particular analogy is simulation environment where you have doors are like square and my apology, windows are like square, doors are like rectangle and so on and so forth, and then there is this agent, think of a robot in an online environment, is going to walk to pick a spoon. Now, you need to figure out, first of all, it's after hitting walls and all that, very 2D kind of environment, you need to figure out that how spoon looks like, you need to know, you have to train and label that an object of this kind is spoon, an object of this kind is a fork and all that stuff. You need to also understand spoon is likely going to be on dining table, so you need to understand dining table, all that stuff. It has to, and fastest possible way, it need to go there, pick it up, and maybe or maybe it need to find it in the fridge, pick it up, close the fridge, all that it has to do. It may not be a direct action, cat or dog. Now, the work or the funding is, you can take 3 months, whatever lifetime for this, then the testing environment they will give a real simulation 3D. Think of this is a 2D simulation environment, this is a 3D simulation environment. This could be inside the room simulator, this could be outside the room simulator. So, simulator to simulator, and then once we become successful, this is phase 1 we are in, then phase 2 would be this, then they will give the phase 3 simulator to this is real world. Now, they will give a robot, you have to take their robot, you can take the agent or machine learning model, they will give you 1 hour, you take that model, put it on the real robot, then you have to place it, and then there will be objects that your simulator, your agent never seen. For example, it understands shoe, but it does not understand slippers. So, you have to quickly, I have to quickly type slipper equal to shoe. So, that means when I am training this, there might have to be some kind of textual prompt engineering where I can say slipper equal to shoe and stuff like that, and it should learn and digest. So, it might have never understood what is spatula, what is a cooking spoon versus teaspoon, all that stuff. It quickly 1 hour, whatever you can do, that is one shot learning. You have one shot and that shot is really small and you can train. At 0 shot learning is basically none. You train some environment, you will be put in a different environment and you should be able to perform. This is probably logical place. So, this is 3 o'clock, let us take a break, we will meet at 3:30.